Welcome to Understand the Math. In this video, I'm going to teach you how to solve compound inequalities. We'll start by learning what a compound inequality is. Trust me, it's not nearly as difficult as it sounds. And then we'll walk through these 4 example problems so you'll know exactly how to solve these types of problems. I'm going to start by quickly going over what a compound inequality is. A compound inequality is just 2 or more inequalities joined together by the word and or the word or. When the inequalities are joined together by the word and, that just means that a number is a solution to both of these inequalities. Let's look at an example. Say we have x is greater than 2 and x is less than 5. The solution to this are just the numbers where both of these inequalities are both true, and that's going to be from 2 to 5. And you can see that here in our graph. X is greater than 2 includes the numbers from 2 to 5, and so does x is less than 5. If there's an or in the compound inequality, it just means that the numbers in the solution are solutions to either of the inequalities. Let's look at this example here. Say we have x is less than 2 or x is greater than 5. That just means the solutions are going to be numbers where x is less than 2 or x is greater than 5. When you have an and, the solution is the intersection of the 2 intervals. And when you have an or, the solution contains both of the intervals. Let's now look at our first example. We're going to solve this inequality. We want to graph the solution and then write the solution in interval notation. Before we begin, I want to point out that this problem could have also been written as 2x minus 4 is greater than or equal to minus 6, and 2x minus 4 is less than 2. Often when you have the same algebraic expression, such as 2x minus 4, you won't write it as 2 separate pieces. When you have an and, you'll often write it just as one single inequality. Let's go ahead now and let's solve this. So we'll write down our inequality. Minus 6 is less than or equal to 2x minus 4 is less than 2. We need to get x by itself, so let's add 4 to all 3 of our pieces. On the left, we have minus 6 plus 4 is a negative 2. In the middle, then, we get a 2x. And on the right-hand side, we have a 6. Now, to get x by itself, we're going to divide by 2. So we have to divide each piece by 2. And this gives us minus 1 is less than or equal to x is less than 3. Let's now go over to our number line and graph this solution. Let's put down a minus 1 and then a 3. X is greater than or equal to minus 1, so we're going to draw a closed circle at minus 1. X is less than 3. There's no equal sign there, so we're going to put an open sign there at 3. And then x has to be all the values in between there, so we'll draw a red line in between. That's the graph of our solution. And then if we were to write the solution in interval notation, it would look like a square bracket at negative 1 because negative 1 is included, and then a parenthesis at 3 because 3 is not included. Let's now look at another example. In our second example, we have an inequality that has an and sign in it. And notice this one is different than our last one because our algebraic expression for each of the pieces is different. That's why we couldn't combine it into one inequality, and we had to have 2 separate ones joined together with the word and. To solve the inequality, let's go ahead and write down our equations. We have 2x minus 3 is less than 5, and we have 5x plus 1 is greater than or equal to 6. Let's solve the inequality on the left first. We want to get 2x by itself, so let's add 3 to both sides. That gives us a 2x on the left, and that's less than 8 on the right. Then we're going to get x by itself, so we're going to divide each side by 2, and we get x is less than 4. Let's now go ahead and let's work on the piece on the right. For that piece, we want to get the 5x by itself, so let's subtract 1 from both sides. That gives us 5x is greater than or equal to 5. And then we're going to divide by 5 to get x by itself, and that gives us x is greater than or equal to 1. Let's go ahead and let's go down to our number line, and let's put the number 1, and let's put the number 4. Let's graph our solution on the left first. It says that x is going to be less than 4, and 4 is not included. So let's put an open circle at 4 and a line to the left. Now let's graph our solution on the right. X is greater than or equal to 1. 1 is included, so let's put a closed circle at 1, and then every number greater than that, so we're going to put a line to the right. Because our problem has an and, we have to find the intersection of these two solutions. That means just finding the points that they have in common. And that's going to occur between 1 and 4. 1 is included, so we're going to put a closed circle there. 4 is not included, so we'll put an open circle there. And then our solution is all the numbers between 1 and 4. We can write this using interval notation, and we write this as a square bracket at 1 because 1 is included, and then we put a parenthesis at 4 because 4 is not included. Let's now look at our third example. This example also has an and in it. I would suggest that you pause the video and see if you can do this one on your own. I bet you can. We're going to begin with writing down our problem. This is 3x minus 5 is less than or equal to 1. And then we have an and in the middle. And on the right, we have 1 minus x is less than minus 4. Let's start by working on our problem on our left. We need to get 3x by itself, so we're going to add 5 to both sides. This gives us 3x is less than or equal to 6. And then to get x by itself, we divide each side by 3. And this gives us x is less than or equal to 2. Now let's go ahead and let's go over to the right. We want to get x by itself, so let's subtract 1 from each side. This gives us minus x is less than minus 5. Now here's where we have to be really careful. We need to divide each side by minus 1 to get x by itself. When you divide by a negative and you have an inequality, you have to change the inequality sign. So instead of saying that x is less than 5, we have to say that x is greater than 5. So I'll just put a little star here so you can remember that whenever you divide by a negative, you change the inequality. Let's now graph our solution. We have the points 2 and 5, so let's add those to our number line. And let's start by graphing our solution on the left. It says that x is less than or equal to 2, so we're going to have a closed circle at 2 and a line going to the left. And then our solution on the right says x is greater than 5, and that means we're going to have an open circle at 5, and our line is going to go to the right. Now what we want to do is find the intersection of both of these solutions. When you look at this, you can see that there are no values of x that are in this interval and in this interval. So what this means is that we have no solution. And that sometimes happens when you have inequalities that are connected by the word and. Let's look at one last example, and it's going to have an or in it. Example 4 has two inequalities, and they're joined together by the word or. We're going to solve the inequalities just like we did the other ones. We'll graph the solution, and then we'll write the solution in interval notation. Let's start by writing down our problem. We have 4x plus 2 is less than or equal to minus 10, and then we have an or, and then on the right, we have 3x minus 4 greater than or equal to negative 1. Let's work on the one on the left first. We want to isolate the 4x, so we'll subtract 2 from both sides. This gives us 4x is less than or equal to minus 12. Now we're going to get x by itself, so we're going to divide each side by 4, and that gives us x is less than or equal to minus 3. Now let's go to the one on the right. We want to isolate the 3x, so let's add 4 to both sides. This gives us 3x is greater than or equal to 3. Now let's divide both sides by 3 to get x by itself, and this gives us x is greater than or equal to 1. Let's now graph our solution, so we'll go down here to the number line, and let's put a negative 3 on it, and then a 1. Because our two inequalities are connected by the word or, both of the solutions are going to be included. So we can go ahead and write our solutions in red. Our first solution is going to be x is less than or equal to minus 3. There's an equal sign there, so we'll put a closed circle at minus 3, and it's going to be less than, so we'll draw a line to the left. Now we have x is greater than or equal to 1, so closed circle, again, we have an equal sign, and our line's going to go to the right because all the points are going to be greater than 1. Now we can write down our solution. Our solution is going to be all values from minus infinity to minus 3, with a closed bracket there because negative 3 is included, and then union because both solutions are included, and then 1 is included, so we have a closed bracket at 1, comma, infinity. Notice that whenever you have an or, you are going to have a union sign because you are going to have two solutions and both of the solutions are going to be included. I hope that you now feel more comfortable solving compound inequalities. They're really not as hard as they seem at first.
If this video has been helpful to you, please consider subscribing to my channel. Keep believing in yourself and have a great rest of your day.